G'day everyone. Today we're going to be learning about how to convert recurring decimals to fractions. In this lesson, we'll be going through the basic process of how to solve these types of questions, as well as taking a look at a few examples. So let's get into it. What we see here is the general process of how we go about solving these types of questions. So when we receive a recurring decimal, we convert it to a fraction by writing the recurring part as a GP. If we don't know, a GP stands for geometric progression or a geometric series. And what that means is it is a sequence with some sort of common ratio. So a geometric progression is something like 1, 2, 4, 8, 16. And here our common ratio R is equal to 2, which just means to go from one term to the next term, we are essentially doubling or multiplying by 2. Now, for the case of a recurring decimal, the ratio will always be between 0 and 1. And because it's always between 0 and 1, this will mean that the series will have an infinite sum. So if we recall, an infinite sum occurs when our common ratio is between that it's between -1 and +1. And the fact that the ratio is going to be between 0 and 1 indicates that we are always going to be falling within this range when we do encounter some sort of recurring decimal. And then we'll be able to use the equation for a limiting sum in order to evaluate the decimal. So what we should know is that the infinite sum of a recurring GP is equal to A, our first term, over 1 minus R, which is the common ratio, whatever that may be. And I guess to give you an example of what a series looks like with an infinite sum, it would be something like 1, half, a quarter, 1/8, 1/16, and so on. So very sort of quite similar to what we had up here, except instead of multiplying by 2, we are now dividing by 2 or multiplying by a half. And what we see is that this falls within our range of -1 to +1. And so that indicates to us that this will have an infinite sum. So if we were to evaluate this, the infinite sum of this series is equal to A, our first term, which is 1, over 1 minus the common ratio, which is a half, and that equals to 2. So what it's saying is that when we add all of these terms together, 1 plus half plus a quarter plus 1/8 plus a 16th plus so on and so forth, what we'll get is, if we keep adding up all these terms, we'll eventually get 2. And so when we break it down to a recurring decimal and try and translate how we convert a decimal to a fraction, let's take the example of 0.3 recurring. This is just equal to 0.333, so on. And when we want to break it down into some sort of GP, what we write is, we write it as the addition of its components. And what I mean by its components is we break it down into its digits. So this 3 here is in the 10ths position. This 3 here is in the 100ths position. The 1000ths position is going to be the next one. And then the 10,000ths position and so on. So what we do is we break it down into each of these components. So we have 0.3, which is the component relevant to the 10th position, plus 0.03, which is the component relevant to the 100ths position, so this one over here, and plus 0.003, plus 0.0003, and you get the gist. And what we see, well, we should be able to see that this in itself is a GP, and we have a ratio of 0.1. And obviously that falls between our bounds of -1 and 1. So that means we have an infinite sum and we're going to be able to... So that means we have an infinite sum and we're going to be able to evaluate this recurring sum. So we'll take a look at some examples now, but this is the general process of how we go about solving these types of questions. And hopefully by the end of this lesson, it will all make sense. So let's take a look. Our first example is to convert 0.1 recurring into a fraction. 0.1 recurring is just equal to 0.111 and so on. When we want to write this in terms of a fraction, well, remember the first step is to break it down into its components so that we get some sort of GP. So we have 0.1 plus 0.01 plus 0.001, and we can keep going, but I won't. Our R is equal to 0.1. Our A is also equal to 0.1 because that's our first term. And we should know that the sum, the infinite sum of this series is going to be our first term A on 1 minus 0.1. And when we plug this in a calculator, we get 1 over 9. Now, what you should be able to do is if you put 1 over 9 directly into your calculator and convert it into a decimal, what you should see is that you'll get a 0.1111 result. And that's essentially how we go about checking our answer. So now let's take a look into a bit of a harder example. This next example asks us to convert 0.78 recurring to a fraction. So the 7/8 recurring is indicated by these two dots above the 7 and the 8. This might also be represented as 0.78 with a bit of a line on the top, and it sort of starts on top of the 7 and ends on top of the 8. And when we translate that into a decimal, some sort of recurring decimal, it just means that the 7/8 component is what keeps on repeating itself. So we have 7/8, 7/8, 7/8, 7/8, and so on. So when we now want to write this in terms of a GP with the sum of its components, what we end up doing is we break it down into the 7/8, and that is what we're essentially going to be adding to each other. So what I mean by this is we take 0.78 and we add that to 0.0078. And the reason why it's 00 is because, well, to get to this second lot of, 7/8, we skip 2 decimal places, or we jump by 2 decimal places. And then for the next term, we're going to have 4 zeros, so 0.0078. And then we can keep going, but I won't. And now what we get is a infinite sum, or some sort of GP, where our A, our first term, is equal to 0.78. And our R, if we take the first term and divide it by, if we take the second term and divide it by the first term, we will get 0.01 as our ratio. So now we should know our formula for an infinite sum is equal to A over 1 minus R. Plugging in these values, we get 0.78 on 1 minus 0.01. And when we want to work it out in a calculator, we eventually get 26 on 33. So yet again, if we wanted to check our answer, type in 26 on 33 into your calculator directly, convert it into a decimal, and what we'll see is you'll get 0.787878. And that's pretty much how we go about doing these types of questions. So let's take a look at our last example, which is a little bit harder. So this is our last example, and it wants us to convert 1.1237 recurring into a fraction. So as we recall from our second example, we have 1.1237. Now the dots are on top of the 2 and the 7, which means we can write a bar that connects the 2 and the 7. And what this essentially means is that the 237 is the component that's going to be recurring. So when we translate that into a recurring decimal, the 1.1 stays the same and does not continue recurring. Instead, it's this 237 component that keeps on repeating itself in that sort of fashion. So now when we want to break this down into a GP, what we do is, well, we have the 1.1, which is what we kind of separate out. And now we continue writing the GP, which is just going to be the recurring component. So the next term is going to be 0.0237 because we've taken out the 1.1, and so that means we carry the decimal place over by one position, which is why we have this 0 over here. The next term is going to be 0.0000237. So we've got this 0, which was the digit that was relevant to the 0.1. And then we've got these 3 zeros here, which were relevant to the 237 in the previous term. And now we've got the 237 that repeats itself. And if we wanted to write the next term, it would have 0.000000237. And we'd keep going, but obviously it gets quite tedious to write out. Now the GP component is exclusively going to be this. Okay, that's going to be our GP. And the 1.1 sort of just stays separate. So this is our GP with our A, our first term, as 0.0237 and our common ratio as 0.001. And remember, we figure that out by taking our second term and dividing it by our first one. And now when we want to evaluate this, well, it's equal to 1.1 plus our infinite sum, which is A on 1 minus R. So when we plug in the relevant values, we get 0.0237 on 1 minus 0.001. And when we evaluate this and plug it into a calculator, what we end up getting is 1,871 on 1,665. So a bit of an unusual fraction that we see here, but if you, yet again, plug it into a calculator, what you'll be able to see is that this becomes the recurring decimal that we had up here. And that's the best way to I guess, check our answer and our result. So this summarizes our lesson for today. Please let me know in the comments if you have any additional questions about anything that we've covered or any future content that you would like to see covered. Please leave a like and subscribe if you're enjoying this content, and I'll see you in the next one.